The moon is our closest cosmic companion, lighting up the night sky and controlling the tides. But here's the shocking truth. It's leaving us. Slowly but surely, the moon drifts farther away from Earth every single year. It's not a lot, just about 1.5 inches annually, roughly the width of a pinky finger. But over billions of years, this small distance adds up. What happens when the moon is gone? The answer is nothing short of terrifying. Imagine tides that no longer rise and fall predictably, days that stretch into weeks, a planet struggling to maintain its balance. Scientists believe that as the moon continues its steady retreat, Earth itself will face massive changes, ones we might not survive. But why is this happening? What forces are at play, silently pushing our lunar neighbor farther into space? And most importantly, is there any way to stop it? Stick around, because by the end of this video, you'll understand why the moon's slow escape is one of the biggest cosmic stories unfolding right now, and what it means for the future of life on Earth. The relationship between Earth and the moon is one of the most fascinating and intricate in our solar system. It's not just a pretty orb hanging in the sky, it's a stabilizing force that shapes life on our planet. Think about it. The moon controls the tides, influences animal behavior, and even helps stabilize Earth's axial tilt. Without the moon, our planet might wobble like a top spinning out of control. Seasons would become unpredictable, climates would shift dramatically, and life as we know it would be thrown into chaos. But here's the kicker. This vital relationship isn't static. The moon wasn't always as far away as it is today. In fact, billions of years ago, it was so close that it dominated the sky, appearing much larger and brighter than it does now. Over time, gravitational forces have pushed it farther away, and that process is still happening. What's causing this drift? And why is it accelerating? To answer these questions, we need to dive into the science of tidal forces, orbital mechanics, and the hidden dynamics that govern the Earth-Moon system. The moon's gradual departure might seem like a slow, harmless process. It'll take billions of years before it's truly gone. But even this steady retreat has consequences. First, let's talk about the tides. The moon's gravitational pull creates tidal bulges in Earth's oceans. These bulges exert a backward force on the moon, pushing it slightly farther away with each passing year. In turn, the moon's distance weakens its gravitational influence on Earth. This isn't just a problem for beachgoers or marine life. It has far-reaching implications for our planet's climate and ecosystems. Then there's the impact on Earth's rotation. As the moon moves away, Earth's rotation slows down. Our days are gradually getting longer, albeit by just a fraction of a second every century. But over millions of years, this adds up. Imagine a future where a day isn't 24 hours but 30 or even 50. How would life adapt to such a drastic change? Finally, there's the ultimate question. What happens when the moon is no longer in orbit around Earth? While that day is billions of years away, scientists predict it would bring catastrophic changes, from wild swings in Earth's axial tilt to dramatic shifts in climate patterns. To understand why the moon is drifting away, we need to look at the forces at work. The key player here is tidal friction. When the moon's gravity pulls on Earth's oceans, it creates tides. But Earth's rotation causes these tidal bulges to lag slightly behind the moon's position. This lag creates a gravitational tug that transfers energy from Earth's rotation to the moon's orbit. Think of it like pushing someone on a swing. Each push gives them a little more energy, and they swing higher. In the moon's case, this energy transfer pushes it into a higher orbit, slowly increasing its distance from Earth. But here's where it gets fascinating. Billions of years ago, the moon was much closer to Earth, only about 14,000 miles away, compared to its current distance of 238,000 miles. Back then, a day on Earth lasted only 6 hours because the planet was spinning much faster. As the moon moved farther away, Earth's rotation slowed down, lengthening our days. This delicate interplay between the moon's orbit and Earth's spin is what's driving the current drift, and it's not stopping anytime soon. So what happens if the moon keeps drifting away? Let's fast forward a few billion years. Without the moon's stabilizing influence, Earth's axial tilt could swing wildly. Instead of a relatively steady tilt of about 23.5 degrees, we might see extreme variations, leading to unpredictable seasons and chaotic climate patterns. Without the moon, tides would also become much weaker, disrupting marine ecosystems that rely on tidal rhythms. Animals like sea turtles and horseshoe crabs, which depend on the moon for their reproductive cycles, might struggle to survive. And let's not forget the psychological impact. For millennia, humans have looked to the moon for inspiration, navigation, and timekeeping. A night sky without the moon would be a stark reminder of how much we've lost. But there's a twist. Long before the moon completely escapes Earth's gravitational pull, the sun will have its own say in the matter. In about 5 billion years, the sun will expand into a red giant, potentially engulfing both Earth and the moon. So while the moon's slow departure is a fascinating story, it's part of a much larger cosmic drama. The moon's slow drift away from Earth might seem like a subtle, almost imperceptible phenomenon, but its implications are profound. From longer days to weaker tides and an unstable climate, the moon's retreat reminds us of the delicate balance that makes life on Earth possible. While we might not be able to stop this process, understanding it gives us a deeper appreciation for our planet and its place in the universe. The moon isn't just a rock in the sky. It's a partner in Earth's journey through space, shaping our planet in ways we're only beginning to understand.